And next topic is the law of conservation of energy. Okay, so we said the energy is conserved at all the position of the object. Okay, see the example. Okay, when an object is thrown vertically upwards, okay, its kinetic energy will be decreases because essentially it is in a ground state. So throwing upwards means, see here, the speed of the ball will be object will be decreases. So the kinetic energy will be decreases. Okay, at a certain height it will be at a stable point. On this stage it has a maximum potential energy. Clear? When object is thrown vertically upwards, it kinetic energy decreases gradually. At the same time, it reaches a maximum in potential energy. Okay. When it reaches the highest point, its energy is completely potential. Okay. Next, similarly, when the object falls back to the ground, okay, from a certain height, its kinetic energy will be increases. Okay, potential will be decreases. Clear? When it is touches the ground, its energy is completely kinetic. It's not potential. Clear? Okay. At that intermediate point, okay, clear? Here, both the energy, there is a kinetic energy and potential are intermediate in this between the points at B. Clear? In a body breathes the ground, the kinetic energy is completely dissipated into some other form of energy like a sound, heat, light, or deformation of the body, etc. Clear? You can throw the object, it come to the ground means you can producing a sound first. Otherwise it can producing a heat, producing a light also. Okay, this meaning of what? The energy is transferred or changed from one state to other state. Clear? So this is a best example for that law of conservation of energy. Clear? So in this example, the energy transformation takes place at every point. See, position A, B, C. So A is the top, C at the ground, so B is the intermediate. Okay, let H be the height of the object. It is reaching a up to maximum point. Okay, now up to B is the Y. The remaining part BC equal to H minus Y. Okay, so the sum of the kinetic energy and potential energy, what is the at the position of A, B and C, we will see. Okay, so first the total energy at A is a maximum potential energy because it has a height, then mass and gravity, and kinetic energy equal to 0, so that the total energy E is equal to U only. There is no kinetic energy. At a B, the U is not equal to 0 because it has some height, so that U is 1, potential energy is not equal to 0. At the same time, the object is moving, so kinetic energy is not also 0. So both are not 0 means what? We write total energy E is equal to potential energy plus kinetic energy. At a point C, that is the ground, U is equal to 0 because H is equal to 0, so that U also 0. Then it has a maximum kinetic energy, but some value is there, so it is not equal to 0, so that the total energy E is equal to only kinetic energy. See, all the position A, B, C, the energy is conserved or constant. Okay, see the statement. The law of conservation of energy states that the energy can neither be created nor destroyed. Okay, so neither be created nor destroyed. It may be transferred from one form to another form. That's it. Okay, but the total energy of the actual system remains constant. That means the sum of the kinetic energy and potential energy remains constant at all the points. Okay, so the formula for kinetic energy equal to what? Of m square. Formula for the potential energy equal to mgh. Okay.